Write the classic game 4 in a row with Python. You can play in your console or terminal with a friend or against yourself. This is what the game will look like. A 6x7 board with emojis for each player and enumerated columns. Whoever can place 4 of their emojis in a row wins. We will use 2 modules. The board will be a numpy array. An OS to clear the screen between moves and matches. I like to define globals or settings next. This allows to easily change the look of a game without having to dig through code. These emojis and their indices will represent empty fields and the players or their coins. I set the board size to 6x7. And lastly we create the board. This is a numpy array, 6x7, filled with zeros. Next our game needs functions. A player will choose a column to drop a coin. The choseColumn function takes one argument, player. It asks the player, no surprise, to choose a column, and instead of typing player 1 or player 2 the player's emoji will be shown. The answer might have typos or extra blank space. We strip that off. Then we check if the player gave us a column number. If not, let's make it clear. We want a number between 1 and however many columns we defined in the settings. Hopefully we got a number and it's in that range. The input function returns strings, so we turn that string into an integer and return this number. With the while loop our function keeps asking until it gets a valid answer. Okay, we stubbornly got a column number. Now the coin needs to be dropped. To drop it we need 2 things, gravity and at least one empty cell in that column. First we get the column. This is a slice of our board. We have to subtract 1 from column number because humans start counting at 1 but Python at 0. So, is there a free cell? Is there a 0? If so we have to find the lowest empty cell. #gravity. Here we collect the indices of every 0 in the column. The largest index belongs to the lowest cell. This cell we change from 0 to the player's index. Remember the symbol list, and exit. But what if the chosen column has no empty cell? We feed back this the player. And since we're stubborn we stay until we get a proper answer. This time not with the while loop but recursion. Yes, if this is your first recursive function, you're welcome. The function calls itself and as the column argument it calls the choseColumn function. So it hopefully get a different column number. Checks the column again, drops the coin or asks again. Don't worry, will not get stuck in an infinite recursion. For the players it would be nice to see the board and the dropped coins. Until now we just used numbers. Human players prefer something more visual. So now it's time to use the emojis. We have to translate the numpy array with numbers to lines of emojis. To iterate through the board array we flatten it. Flatten turns it into a one-dimensional array, basically a line of numbers. Each number we use to pick the right emoji from the symbols list. The last bit reverses the flatten function and reshapes pretty board to a 6x7 array. Print the column numbers human style, starting at 1. That F string formatting after the colon adds extra space to each number. The emojis take up more space than any regular character in the console. This way each column number is on top of the respective column. This line of code prints the emojis row by row with spaces in between. Choosing columns, dropping coins, that's all the players do until a match is over. Either a player has won or the board is full. Let's write the function for the latter first. It's easy. The board is full if there is no 0 in the array. To check if the current player has won is a bit more complex. The computer is blind. We need to check rows, columns and diagonals for sequences of 4 equal values. Rows first. We loop through all of them. We will write another function has 4 in a row, that takes 2 arguments, a sequence and the value representing the player. The has 4 in a row function will return true or false. If the player has 4 in row, we exit this function by returning true. If not, we check the columns. Loop through all of them. We need slicing to do so. With each column we feed the has 4 in a row function. And again move on or exit with return true. Last direction to check is diagonally. Tricky. We need a function to get the diagonals. But apart from that it's the same. We check 4 in a row or not. And return true if so. If not, the isWinner function will return false. Okay, here we go. The has 4 in a row function takes a sequence. That's a row, column or diagonal. They all are iterables. We will loop through. We do 2 true or false checks here. We use any and all. We need to find a sequence where all 4 continuous items are the same. This is what the line starting with all does. The sequence is a row, column or diagonal. They can all be longer than 4. So we look only at a chunk of 4 items in that sequence. When all 4 are the same it will return true. The outer loop is the any function. It will iterate through the sequence getting every possible 4 item long chunks. If any chunk is a 4 in a row it returns true. Has 4 in a row was one of 2 functions our winner check needs. Get diagonals is the other. To collect all diagonals we create an empty list. We loop through range of rows and columns to pick the 4 cells each time. With -3 we make sure there are always 3 more row or columns left to pick from. In a numpy array we can point to cells with lists of indices, not just a sing index or a range. The first list has row indices. In the second list are columns indices. For diagonals going from top left to bottom right we add 1, 2 and 3. The same in the other direction with -1, 2 and 3. This picks 4 cells, stores them as a sequence in the diagonals list. And we return the sequence. Done. That was the heavy part. Just 2 easy functions left. Why not play another match, we'll ask. Still stubborn, a while loop offers its service. If the player types y in upper or lower case the function returns true. It will return false if the answer is n, or it will keep asking. The last one is for good looks. This clears the screen between moves and matches, so the players only see the current board. The function checks if the operating system's name is NT. This is true if you are on a Windows computer. Then CLS is the console command to clear the screen. For Linux and Mac it is clear. We have all functions for our game. Take a sip of coffee for the final stretch. We want to run it from the terminal. This line says, if this file is called, do what follows. We set a status for the game and a match. The first player will be player 1. The first thing the players will see is the title of our game. And the empty board. The following will loop until the players quit the game. Within the game loop is a match loop. Every loop a player gets to choose a column. The coin is dropped. Before the board is printed we wipe the screen, so players will always only see the current state. Then we check if the current player has won. Or if the board is full. In both cases the match is over. We print feedback and exit the match loop. If the match continues we switch players. We multiply the players' number with -1. Using -1 and 1 is the shortest way to set 2 players and their emojis in the symbols list, since the last item has the index -1. Finally, if a match is over, we ask to play again. Happily re-enter the match loop with true. Or grumpily exit the game. Followed by an equally passive-aggressive screen cleaning. Well done. You can now run 4 in a row in your console. Enjoy. Do you like the game? What's your best strategy? Let me know in the comments. You know you can change the emojis in the settings. Which emojis do you use? Leave a comment with yours.